we're going to add and subtract some rational expressions that already have common denominators. So first off, it has a common denominator. Go ahead and write it as one fraction, and then see if you can simplify. I can take 12 minus 2 and make it 10. And then if you look at your 5 and your 10, you can divide out a common factor of 5 and just get 2 over x. Same idea on this one. So you already have a common denominator for your two rational expressions. Go ahead and write them as a combined single fraction. Now, if you're adding, you can't add 3x and 1 together because they're not like terms, and you also don't have any common factors between all four of those individual terms. So there's nothing you can divide out, and you are done. The ones that we just did already had the same denominator. So a quick reminder, if you have two fractions that don't have a common denominator, think about what your least common multiple is going to be. So like my multiples of 4, my multiples of 6, find the smallest one that matches, and that's going to be your common denominator. Or you can factor each of your denominators, look at what factors they have. So it's got a 3, so my common denominator has to have a 3. And I also have factors of 2. Now, the larger amount of factors of 2 has to show up, so comparing one factor of 2 versus two factors of 2, I'm going to have 2 factors of 2 in my common denominator. If I multiply those together, I'll end up with 12, so that's my goal for my common denominator. I can get there by multiplying my first fraction by 2 over 2 and my second fraction by 3 over 3, and then I'll end up with 10 over 12 plus 3 over 12. Now they have a common denominator, I can actually add them together and get 13 over 12. So that's the same idea that I'm going to do with my rational expressions. First thing I'm going to work on is finding least common multiples that will be my least common denominator, because it's going to be important that I actually get the least common denominator because it makes our life so much easier. So if I look at these two expressions, let's compare the factors that they kind of have in common here. They share some factors of x, they share a factor of x plus 2, and there's also this random factor of 3. So any factor that shows up in either one has to be part of my least common multiple. So I need my factor of 3, I need some factors of x, and I need some factors of x plus 2. The least common multiple has to have the amount of factors that shows up the most. So of my x versus my x to the fourth, I need the one with the higher power, x to the fourth. And of my x plus 2 versus my x plus 2 squared, I need the one with the higher power, so x plus 2 squared. So my least common multiple of those two expressions is 3x to the fourth times the quantity x plus 2 squared. So finding that least common multiple is going to be my goal for this pair of expressions. Now, if they're not already factored, I need to go ahead and factor them so I can see what factors I have. So I'm going to factor this 5x squared minus 45 into 5 times x plus 3 times x minus 3. And then for my second expression, I can factor out a 4, which leaves me with x squared plus 6x plus 9. And then I can find the two numbers that multiply to 9 and add up to 6, which would be 3 and 3 to rewrite my 6x. I could pull in x out of my first two terms and then a 3 out of my second two terms, which means this is going to factor into x plus 3 times x plus 3 times my factor of 4 that was already factored out. I'm going to write that as x plus 3 squared because those are two of the same factor. I'm also going to go ahead and take 4 down to 2 times 2. Just because it makes it easier to think about my numbers. So I kind of like to highlight all the different factors I have. I have factors of 5, factors of 2, some factors of x plus 3 in both of my expressions, and then I have another factor in my first expression of x minus 3. So I basically have 4 different types of factors here. Looking, I need any factor that shows up in either one, and the higher number that appears like exponent-wise. So I have a 5, I need my 2 factors of 2 squared. And then for my x plus 3 factors, I need my x plus 3 to the second, because that is the largest amount that appears. And then I need my other factor of x minus 3. I'm going to go ahead and multiply my 5 times my 2 squared and get 20. And then my least common multiple of those two expressions is 20 times x plus 3 to the second times x minus 3. So let's actually do one here that doesn't have a common denominator. If you think about your least common multiple, if you factor those denominators, it'll factor your 8 will into 2 times 2 times 2. And then your 12 will factor into 2 times 2 times 3. And now if you look at your factors that you have, some factors of 2, factor of x, and a factor of 3. So you need the largest amount of 2's that shows up, 2 2's versus 3 2's. You need 3 2's, and you need your 3 and your x, which gives you, if you multiply that together, least common multiple, or the goal for your denominator, of 24x. On this one, you might have been able to figure that out without factoring by just listing out your multiples of 8 and 12. So if you think about what I need to multiply each of these by to get my denominator to be 12x, well, I need to multiply 8x times 3 over 3 and 12 times 2x over 2x. So if I do that multiplication, I'll get 9 over 24x minus 2x over 24x. Since they have the same denominator, I can write them as a single fraction, and it happens that I can't simplify or combine any like terms there. Now, if you have fractions that don't have a common denominator, you're going to need to find that least common multiple of your two denominators to use as your least common denominator. So let's go ahead and factor my denominators. I can factor 3 out of the first one. The second one, I'm going to rewrite my middle as negative 5x plus x, and then pull out some common factors to make it x minus 5 times x plus 1. Now again, I'm going to look at all my different factors that appear. I have a factor of x minus 5, factor of x plus 1, and a factor of 3. So all three of those have to be in my least common multiple that I'm going to use as my common denominator. So my goal is to get both of my denominators to be 3 times x minus 5 times x plus 1. So let's go ahead and rewrite my original expression in factored form for my denominators so I can see what I need to multiply by. So if you look at your first denominator of my factors in my least common multiple, I'm missing the factor of x plus 1. So I need to multiply that first expression by x plus 1 over x plus 1. If you look at my second fraction, I'm missing the factor of 3. So I need to multiply that one by 3 over 3. I'm going to add some parentheses here to remember that I'll have to eventually distribute. Move this out of the way a little bit. Okay, so let's go ahead and multiply to get that common denominator. So I'm just going to write it as multiplication and not actually distribute yet. So if I do that, then by multiplying by those missing factors, I will have the same denominator in both of my rational expressions. And now that I have the same denominator, I can go ahead and write it as a single fraction with my minus in between my two expressions on the top. And now I'm actually going to have to take the top and simplify it because I could multiply x times x plus 1 and distribute my negative 3. And then on top, I will be able to combine some like terms. So that'll give me just x squared minus 5x minus 6 on top over my 3x minus 5 times x plus 1. Now I don't really need to multiply the denominator together. I just wanted to do my operations on top so that I could combine those like terms. Now actually on top, I can factor that. So I can rewrite my middle as negative 6x plus 1x and then factor an x out, and I'm going to be left with x plus 1 times x minus 6. If you think about your denominator, you have a factor of x plus 1. So actually, I should divide out that common factor. And then my completely final simplified version is x minus 6 over 3x minus 5.